server, or to pass through an authentication. So you can use fuzzing to test software stability, but also the security or the quality of the software. And all of the fusing is done in the point of view of the offender. So your goal is really to crash the program, and you want to crash it, you do what you want for it. And the advantage of fusing in comparison of static code analysis or dynamic code analysis is that fusing is really simple, which means that in 4 hours you can write a fuzzer and find the first bugs. It's very fast because most fuzzers find bugs in 1 minute or maybe 1 hour, but that's very fast if you compare to static analysis, which can take many hours. I think it's also efficient because you are sure that you are able to crash a program. Because if you read the source code and you find a strange memory code, it's maybe possible to crash it, but you are not sure and you don't know exactly how to crash it. Whereas with fusing, you have already the data to crash the program. And fusing can be used on the free software. You consider the target as a black box. So you just send data and you watch the reaction, but you don't need to read the source code. So it's also possible to test closed source software, like Microsoft, all software running on Microsoft Windows. Fusil is my program, my further project. So it's a Python library with a lot of tools to create a process, to watch the standard outputs, to watch logs, to watch the memory usage, to watch the CPU usage, etc. But it's also more than 20 fuzzers. One fuzzer is very specific to one target, like GIMP, Clamave antivirus, and a lot of similar. There are a lot of different fuzzers. And with Fusil, I already found bugs in a lot of software like Clamave, GIMP, the GNU libc, but also Python. And the Fusil main target is a command line program on Linux, but you can also test a network server. You can test Firefox, which is a graphical application. The different input vectors, they are the command line, the files, the environment variables, the TCP sockets, UDP sockets, etc. And the probes to watch the software reaction, to watch if the software is still running, if it takes a lot of memory, etc. There is a standard output, the logs, the process exit status, which means an exit code or the process killed by a signal. And the networking is used on the remote servers to test that, to try if the server is still running or not. And there is also an integrated debugger, which is called Python PyTrace. In Fusil, I use approx core systems, which means that each probe has a score, and you do the sum of all probes, and you can also give a right to the probe to say that if you have a lot of false positive, you can use a lower score, a lower rate for the probe. A score of -1 or -10% is input rejected. 0 is nothing special, and the higher score means simply a crash. In fusing, we use 3 different types of data generation. The first, most easy technique is to generate pure random, like the example with Netcat. But this technique only works on very on software with no QA, with no security, which means also no user or very few users. So we prefer in fuzzing to inject false, invalid data. So you can take a JPEG picture or a movie or anything, any file, and when you replace some bytes, you invert bits or etc. You can also truncate the file. And this technique is very efficient because all video players crash. And it's also the easiest technique, easiest because the first one doesn't work on a real application. And the second main technique is to generate data using a model, which means that you read the specification of a format, like a PNG format, and you generate valid data, valid respecting the specification. And such tests go deeper in the program because you pass through the first test, which tests that the program the file is valid or not. But the problem with this model is that you need a specification. An example of a fuzzer is a Python fuzzer. So the first step is to list all Python models. The second step is to list all functions. And then you do a random function call with random arguments. So it's very, very stupid, but it works very well. Example of a fuzzer in Fusil, there are the Clamave antivirus fuzzer, which already found a critical bug. The bug was on a Microsoft Office document with a single file of 10 kilobytes. You are able to crash a server. There is also the Firefox fuzzer, which means that you can test any embedded content. So a picture, a video, SVG file, anything that you want. There is also many audio-video player fuzzer, like GStream and Player on VLC. And ImageMagick, which is a library to convert any type of picture from one format to another, but also to modify the picture. I have also fuzzer which targets a library like getText. getText is a library to translate English to any language. And I like this fuzzer because it works very fast and it always crashes the program. There is also Poplar. Poplar is a library to display your PDF documents, and it's used by events on KPDF. And finally, there is also a printf fuzzer. The printf generates random calls to printf, but with valid data and valid format string. So it's a test to make sure that the printf works correctly. And finally, there is a fuzzer specific to one programming language, like the Python one, but also fuzzer for PHP. With the Python fuzzer, I found something like 10 bugs or maybe 100 bugs. There are a lot of bugs in Python. And the algorithm is, like I said, a random function call with random arguments. An example of Fusil. So you just type the name of the fuzzer. It generates a lot of function calls. Here I test Python 252. It tests each time it tests a different module. And here we have a crash on a local module, which is a invalid memory read from a null address. By default, the fuzzer stops at the first crash, so in 6 seconds, it's already found bugs in Python. And when we have a crash, Fusil stores all data in the directory. Here it's a directory Python -2. We have the project log, which are all logs of the project, and a subdirectory for each crash. In the directory name, you have already the information about the crash. So first the module name underscore local, but also the type of the crash. Here, invalid read from null address. In the directory, you have different file. We play the script to replay the session. Session.log is all logs from this crash, the specific crash. stdout is a standard output, etc. Here you have session.log. It repeats the same information, so invalid memory read. And you have also the score of 200%. You can replay the crash with replay.py. It's the same crash with getText. It's very important to replay the crash because you need, for example, to run it in a debugger. If you add --GDB, you are able to replay the crash in a GDB. And here you can get more information, for example, the backtrace. You can also read the assembler code. You can dump register, etc. So here it's an invalid read with the RRX register, which is new. And you have also the backtrace using where. So here you have a bug in the local module. We have some point d'interrogation. There are some information missing because you need to recompile the program with debug symbols. Here it's the generated script to test the local modules. So they are only a random function call. For example, here the local conf with integers, then with Unicode string, then with Boolean, etc. And we test all functions from the module with different arguments to make sure that Python doesn't crash. When you have a crash, then there is a most important point to analyze the crash. So first, the criticality of an error. The denial of service is the most typical type of error, which means that the program crashes or the server stops to answer to the client. To measure the criticality, there are different criteria, like losing data. You are working in a very important file, and if the program crashes, you lost all your work. Permanent error means that every time you can, if you quit and restart the program, the error is permanent. And then the difficulty to reproduce the error, which means that, for example, you have to set a specific variable environment, you need a specific language, you need a specific file. So it depends on the error. And the second question is it a bug or a vulnerability? A vulnerability means that you can steal data, so read anywhere in the memory or read anywhere in the file system, or modify files. So write, for example, you can deface a website, or the most interesting point is to inject code. So you can execute your own code. When I send bugs to the editors, there are three different types of answers. The first answer is that we don't care. For example, the getText author just tell me that he want performances, he want getText to be very, very fast, but he don't care to security. The second type of error is to apply patches. So the editor just take my specific crash and fix it, but he doesn't try to test if there is a similar error. And the last type of answer is an editor interested to test Fusil or to test similar tools to test the software quality. And in my point of view, it reflects the project quality. Because if the project rejects a patch or don't care, it means that the program may crash or has a lower quality. Some ideas to generate new faults that are not implemented yet in Fusil. We can use fail memalloc. It generates error in memory allocation. You have to use dev full. It's a specific device. You can read some data from this device, but after 10 bytes, it generates an error. Another idea is the time jumps, which means that you can change the system clock and make sure that the program doesn't crash. You can also send signals, process signals like sig user, sig term, sig fault, or something like that. And also network fuzzers, because most Fusil fuzzers are specific to program using files, like GIMP, Clamave, etc. are all working on files. It's very interesting to test network clients or test network servers. There are different fuzzer libraries, explained later, which are specific to networks. Other idea for new probes. The probes, for example, code coverage can be very useful to make sure that we go deeper and deeper on the program, because we must further only test the first phase of the, how can I say that? It only make sure that your file validity is correct or not. With code coverage, you can make sure that you are deeper in the program. So for code coverage, you can use Jcov or Dynamo Rio. There are also memory faults using Valgrind or Purify, because sometimes the program doesn't crash, but if you replay the same session, it will crash because of some memory bugs. Fusil is only one library, but there are a lot of other free software fuzzers, like Sully, Pish, and EFS, which are the three most important libraries. But there is also Bunny, Flyer, Scapy. I think Flyer is the most interesting because it uses Valgrind to make sure that you don't have some strange memory errors. But it also uses Valgrind for the code coverage. Last year, Samozva presented ZUF. And there is also Spike and Protoss, which are network fuzzers. So while using a Fusil instead of another fuzzer, first idea is that Fusil is main program, so it's the best. But also that Fusil is very good to run it in a whole night. It collects data and it doesn't need human interaction, because you can ask to stop after one crash, but you can also ask to crash after 1,000 bugs or more. And it only keeps the success files, which means the crash, files related to a crash. So if the session is not interesting, the files are just deleted. There is also a replay script, so you can make sure that the program still crash, or you can replay the session in a debugger. You can replay it in Valgrind. And there is, and Fusil generates crash information. Like in the demo, you have the module name, you have the type of the error. You have also the environment variables. You have a lot of information about the crash, which is very important to detect duplicate crashes. And safety, because Fusil is running in a different user. It is running under the Fusil user and not your own user or root user. It's very, very dangerous to run a fuzzer in a computer because you can delete any file on your computer. You can kill any process. You can write very stupid data in your files, etc. So it's very important to use a different user. There is other protection like memory protection. The fusing process is limited to 10 megabytes or a little bit more. There is also protection about time, which means that if the process is running more than 60 seconds, it's stopped. So to conclude, Fusil is distributed under the GNU GPL license. It's running on Linux, but you can also use on any POSIX compliant OS like FreeBSD, but also Mac OS. Or you can also try to run it on Windows, but there is no tool to test a graphical application. There is no tool to catch message boxes. So you may try other fuzzers like Sully. And Fusil is written for Python 2.5, and you have the URL below. So do you have any question? Yes? Yes. The coverage of the program?
How do you check that the coverage of this data is wide enough to cover enough of the possible cases?
Yes, the question is how can I know that I tested all specification of the file format? For example, if I test a JPEG file, there are a lot of different chunks. The answer is that I don't know. You have to, it depends of the method. If you inject false, invalid data, you will only test the death specific file. So you have to use 10 files or more to test different type of chunks, of file chunks. And if you generate data using a model, you have to implement the word format. So you know that each type of chunks is tested. Yes?
In your experience, what is the most common cause for crashes, and what should developers do to prevent those types of crashes?
The question is the most typical cause of crash. The cause is always the same. You have to validate inputs. It's very common on a web application. You have to validate each field in the form. It's the same in any program. You have to make sure that the image size is, for example, between 10 or 20, but not 1 million or 4 million. And yes, you have to validate the inputs.
And is it true that performance is trade-off? You have a movie player that's fast, and you do all the
But the performances, it's not true, because you can add some checks. It's very, very cheap to test that a field is a certain interval. So it doesn't impact the performances. And another code of crash is simply bugs in program. For example, you allocate memory, but you doesn't check that the memory is really allocated. Yes?
You said there was some safety in Fusil. I wonder, did you use fuzzy to first fuzzy, or do you plan to use fuzzy to first fuzzy?
The question is, did I test fuzzy on fuzzy? The answer is no. I don't plan to test fuzzy because I know that there are bugs in fuzzy, but I don't. Yes. But I don't want to test my own further. My goal is to test software like games or other programs. Another question? I tried, but I don't found bugs yet. But there are different further, like sysfuse, which do random system calls. But you have to to generate a random system call doesn't work. You have to write the same structure. Because if the system call has a very invalid arguments, the inputs are just rejected. But yes, there are further for the Linux kernel, but also for Windows kernel and to FreeBSD kernel, etc. It's very interesting to test the kernel, because if you find a bug in the kernel, you are more the root user, you can do anything you want. Yes? Excuse me? J'ai pas entendu, quelqu'un a compris.
Fusil tests some graphical programs with Qt, JDK.
Mm-hmm. I tested Firefox, but the interaction is very low because I run Firefox with an URL, and then I just send a special key, the F5, to refresh the page. But testing a graphical application is a little bit more complex because you have to script the action. But most of the time you don't need to test a graphical application because, for example, to test KPDF or events, you don't need to test the graphical application. I use the PDF to text, which is a command line program. And if I found a bug in a PDF to text, I'm sure that events on KPDF will also crash. And for example, for the GIMP, I didn't test the graphical application because there is a command line. It's possible to script GIMP with the command line. And it's similar for most applications on Linux. You can use the command line to test the program. Any other question?
Is it high on CPU to run fuzz data?
The question is about the CPU usage for fusing. I don't know. It's usually high, but it depends on the program. For example, if a program takes 10 seconds to open the file, sometimes the CPU usage is very low. But if you find a denial of service, really a crash, the CPU usage can be 100%. Other question? Yes?
What will be the feature of the
The? Oh, okay. The feature of the future. Here are some ideas to find more bugs. I'm very interested in network further because it's a little bit more funny to test a program in a remote position. But there are a lot of ideas. You can do anything you want with a fuzzer. The idea is to find new ways to test a program. For example, if you test ImageMagick or Firefox, you can test the JPEG file format. But it's not very interesting because it's already done by other people. The idea is to test rare format like SVG or some video file format. So I don't have a static plan for the future, but there are a lot of ideas to go further. Other question? Yes?
Why did you write it actually? Were you not happy with the existing fuzzers or?
Why did I want Fusil? I'm a hacker. I like programming, and it was easier for me to write a fuzzer with my own code, because for other frameworks you have to learn how to write a fuzzer, and also main fuzzers of this list are targets Windows on graphical application or network application, but I prefer Linux command line programs. Each fuzzer has a typical target, like Fusil is Windows target closed source programs. Protos is more to network programs, and Fusil is more for Linux command line programs. Yes?
Are there any relation between the other program you wrote, who is interested in performance, and Fusil?
Is your question about Ashwar? Yes, I wrote. The question is it a relation between Fusil and Ashwar? I wrote Ashwar. It's a generic library to parse file format. I used Ashwar to test RPM program, because you have to recompute the checksum, and in each RPM the checksum has a different position. So I use already Ashwar to test Fusil. Okay. Other question? Yes?
Is it easy to implement a new fuzzer to test, for example, my own application?
The question is it easy to write a new fuzzer? For me, it takes 1 hour to write a new fuzzer, but most of the time the fuzzer is very easy to implement, but then you have to analyze the crash, and that's a typical point. The analyze crash takes more time. And writing a fuzzer depends of the interaction. For example, for GIMP, you have to write a script. For Clamave, you have to generate files and run a specific program, which is very easy. So it depends of the target and how you run the program. But usually it takes less than 1 day to write a new fuzzer. It's very fast. But the problem today is that nobody cares about security. Other question? So thank you.